For the first time in this course, we will do the exercise first and then go on to the presentation. The reason is that I want you to see clearly the difference between configuring RIP and configuring OSPF. Of course, we will use the same topology we did in the RIP exercise. Let's look at the commands first. We can take router 1 as an example. There are two networks directly connected to router 1, 1 and 3. And as in RIP, we need to add these networks to OSPF as well. The command is similar to the RIP one with some additions. Those additions are first the subnet mask, which is in wildcard mode, and this command also has the area number. I will explain later in the explanation video what are areas, but for now, all these routers in this network will belong to the same area, area 0. Area 0 is the backbone area, and you must have that area in your OSPF network. If you have several areas, one of them has to be area 0, and if you have only one area, that one area must be area 0. In short, OSPF areas exist to make scalability easier, but we'll get to that later. As for the wildcard mask, if you're not familiar with IP addressing and/or subnetting, go watch my course IP Addressing 0 to Hero. I'll happily send you a voucher as well, just send me a message here on Udemy. But you don't need an entire course to understand wildcard masks. In short, you get a wildcard mask by inverting the bits. So if you write the regular mask in binary numbers, you will get the wildcard mask by simply replacing zeros with ones and ones with zeros. In plain English though, each of these octets maximum value is 255. So this mask in the regular format would be 255, 255, 255, 252, and you get this wildcard mask by simply taking, for the first octet, 255 minus the value that you have here, that's 0. And then for the second octet you do the same, and then for the third octet you do the same, and then for the fourth octet you do the same. Only this time we have a 252, so we will calculate 255 minus 252 and we will get 3. So that's how we got this wildcard mask. Now let's look at the router OSPF 1 command. That's the first command we need to use. Number 1 here is for the OSPF process ID on this router, so it's only locally important. You can have a different process number on each router. We won't have any examples in this course on any useful way to configure different OSPF process IDs on one router, so I'll just tell you an example of when I would use it. I had one time this gateway router with, I believe it was around 20 networks connected to it, and I had to list all those networks inside of an OSPF process. So it's like you had 20 networks to list in here instead of 2. And these were real routers, so I connected to them via Telnet. Don't tell anyone about it. But the routers were previously configured by another administrator and he mixed up the host names. So if we look at this topology here, imagine we configured router 5 as if it were router 3. And that's exactly what I did. I configured those 20 routes on the wrong router that still needed to have OSPF. So instead of reversing all of the commands by typing in no and then repeating all commands for all 20 networks, I just said no router OSPF 1 and created a new process, router OSPF 2, and then configured the right networks. Alright, that's pretty much all I wanted to explain prior to configuring this topology. So let's get going. As in RIP, everything is pre-configured, so IP addresses on interfaces are obviously switched on, and we need to configure OSPF. All of the routers will belong to area 0, so we will not have multiple areas in this exercise. And then we are required to configure the passive interfaces. They're exactly the same as in RIP, and the command is exactly the same, so I believe we can get going. As always, I'm going to start from router 1. Router OSPF 1, and then list all the networks that are connected to router 1 with a wildcard mask and area number. So it's going to be network 1000003 and then area 0, and then the same for 3. I'm just going to edit the first command. And that's it for router 1. Let's go to router 2. Enable configure terminal. Router OSPF 3, for example. We can use any process ID we want. And then on router 2, we have 1, 2, and 4. So network 1000, wildcard mask is 0003, area 0. And then similar for network 2 and similar for network 4. And that's it. Let's go to router 3. Enable configure terminal, router OSPF 1. We got networks 2000003, area 0, and then we have 10.1.0.0, and this time the wildcard mask is different since it's /24. The regular mask would be 255.255.255.0, so we just need to flip it, so it's going to be 000.255 and then area 0. And I'm going to use the same command, slightly edited, for 10.2. Okay, we got this information that this router became neighbors with probably router 2. And we can configure the passive interfaces here as well. The command is the same as in RIP, so passive interface gigabit ethernet 0/0, and then the same command for 0/1. That's it for router 3. Let's exit. We can move on to router 4 right away. Enable configure terminal, router OSPF 1. We have lots of networks here, so we have 3000003, area 0, and then similar for 4, 5, and 6. We already have some neighborships being established. Okay, this is with routers 1 and 2. We can move on now to routers 5 and 6. Enable configure terminal, router OSPF 1, network 5000000.3, area 0. And then on to router 6. Enable configure terminal, router OSPF 1, network 600000003, area 0. Adjacency established, that's good news. We can move on to now, for example, router 3 to look at the routing table. I'm going to say do show IP routes. We can see all of the networks here, and instead of all those RIP routes, now we can see OSPF routes. We can see the administrative distance value here, and this is the OSPF metric. Similar as RIP, only In OSPF, we use a different kind of metric. Let's go on to test the connectivity. It should work since we have all of the routes in the routing tables, although we have only looked at one router. I'm going to do this. So that's successful, and then this is successful, and then let's try this. That's pretty much it for this OSPF exercise. See you in the explanation video.